conditional on the position being. Good morning, good afternoon, or good day.
Good day.
Morning.
Hi, Ahmadou. Let's wait a few more seconds for others to join.
Ciao Carlo.
Buongiorno.
Buongiorno. Non c'è nessuno ancora, no?
No, Flavia, ci sono 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 persone già.
Ah, perfetto.
Hello.
Hello.
One day I will need to understand how many people should we expect. It's 12 for now.
Che non vedo nessuno.
Okay, so let's start as usual by giving those who have connected early an opportunity to ask questions if you have doubts or comments on what we discussed last time. As usual, either just unmute yourself, ask the question, or write in the chat. I will try to keep my eye on this. Okay.
Yes, I wanted to ask a question, maybe not directly related to what we did last time. I would like to know, because so far I think we are discussing about items with dichotomous items, 1 or 0. And I wanted to know if, for example, we wanted to use item with more than 2 response, if the methodology is the same or not.
A good question, Ibrahima. Yes, there is a version of the Rush model that accommodate responses that are not simply dichotomy, but responses that are graded. So, for example, when you say low, middle, high, rarely, sometimes, often, and for all this version of the questions, there is a version of the Rush model that is called the partial credit model or the graded response model. And if you have had an opportunity to look into the Bond and Fox book, I think there is a specific chapter that discusses how to deal for those data. In the context of the food insecurity experience scale, we also have a version that allow to treat questions that are asked in this way. You ask, have you ever experienced this condition? Yes or no. If they say yes, then you can ask a follow-up question to ask whether it was rarely, was sometimes, or was often. So to make a response graded in terms of the frequency. And we normally do this only for the more severe questions, for a reason that we will probably discuss, not today, but in maybe next presentation. But the answer is yes, there is a very established model. We have even implemented in the software that we will be using today. So it will be very easy to demonstrate its use. The big question, however, is not any question that is asked on a graded scale can be considered consistent with the idea that we are measuring one single latent trait. And there are cases in which the data that you have provide information on more than one dimension. And so the frequency of the food insecurity experience and the severity of the food insecurity experience are two different things in general. So one thing that we will discuss, again, not today, is, are we sure that we can collapse the frequency of occurrence on the severity scale? And the question I will pose is, are we sure that being exposed to a relatively mild condition in a frequent way is comparable to being exposed to a more severe condition less often? So can you trade off frequency and severity? And my answer is, in general, no. You need to classify along two different dimensions, one that is the severity and one that is the frequency, so that you make a distinction between households who are, for example, frequently compromise the quality of their food, but they really never reach the point of reducing the caloric intake. And other households in which normally have a good variety of food, but sometimes there is a scarcity that compromises the quantity. So I would be extremely careful before saying that you can collapse two different dimensions onto one single measure. And we already commented or mentioned en passant before that, for example, with the food consumption score, which clearly collect information on the quality of food consumption and quantitative aspect of food consumption, this automatically gets done, but gets condensed, synthesized in the same value of the food consumption score. So, for example, you may have a household that reports a food consumption score of 42, but this can be the result of different combinations. Some combination that imply only eating a few of the food groups, and another that is because they are eating it only in some days. Are we sure that we can combine them into a single scale? So before being able to say yes, you need to prove that indeed this different combination of data that leads to the same score have the same substantial meaning. And in general, this is not the case. In those cases, there are other techniques that are multidimensional Rush models, in which instead of working with one variable, one latent trait, you work with a vector of 2 or 3 different variables. Okay? Okay, I see now we have 14 people on board. Let's start. And welcome again for joining this online training on the FIES. I remind you that we are recording this, and I make the recordings available to everyone. So what I wanted to do today is to move into demonstrating an actual application of the food insecurity experience scale and the analysis of the data using a software that we have developed at FAO under the R framework. So what I will do I will share my R screen. Let's see if I can make this visible to everyone. And I would like to ask you to confirm that you see my screen. And also, please tell me if it's sufficiently visible so that you can read the text. Okay. So what I'm going to do today, and I guess Nicholas will be happy, is to use the data that Nicholas shared with us on the food insecurity experience scale collected in Sudan in the food security and nutrition monitoring. And we have been given data from 2 rounds. Yes, Nicholas is very happy. Good. And in 2 rounds, the 23rd round and the 25th round have included FIES data. So what I will do, I will present you a script that is written in R language using the R Studio, which is a user interface that facilitates the interaction of the analyst with the R processing machine. That is a software that does all the computation. So I assume that most young researchers like you guys these days are quite familiar with R. If not, I will suggest, I will send you a few links. There are plenty of online courses that present an introduction to R that should be able to give you the fundamental ideas. Why R? There are several reasons. The first and most important one is because this is a completely open source free software. So anybody that has access to internet can download the software, install on their machine, and run the analysis. There is no need to pay any license, to make any registration, to receive any authorization whatsoever. And that is the reason why we at FAO promote the use of R, because that will not imply imposing any cost on the user. The second most other very important reason is that it's probably by far the best software to do statistical and numerical analysis now on a personal computer. And the only relative difficulty for people who are more used to either Excel or SPSS or Stata is that the way in which you program your analysis, you actually operate, it's a little bit more different. And I find it very easy, but I have to admit many people find it a little bit more difficult. So those of you who have programmed in things like MATLAB will find this very easy. People who do not have programming skills might find it a little bit more difficult. But anyway, let's go on and let's see how easy it comes. Essentially, you see my screen is divided in 4 panels, one of which, this lower bottom left panel called console, is the actual R console. So if I write in this window, it is like I were interacting directly with R. And the way you interact with R, there is a cursor, you type in a question and R responds. So if I type in a question and then press enter, I get the answer. Of course, the question you ask R are mathematical, statistical, graphical questions. And then the answer is appropriate. 2 plus 2 is 4. The sine of 2.54 is 0.5659. And 3 to the third power is equal to 27. The square root of 81 is 9. So all this kind, it's the logic. Okay, so very easy. But of course, it's useful when you have to do just one thing. The easier way of working with R is to prepare instead what is called an R script, in which you can do several things. Define variables, and write commands. So you will have a series of commands that then you can run one at a time or all together by transferring the commands from your script to the console. How do you do this? You just go on the proper line and press at the same time Control and Enter. So if I do this on line number 1, what is in that line gets transferred to the console and R registers the outcome. So now, as you see, I have issued the command defining a vector. And this vector has been saved into the working environment. The working environment is where I can see all the kind of data that I have that are available for the analysis. So now I have defined a vector, I call it X, and my vector is made of 3 numbers, 1, 2, and 3. Then I defined another vector that is called Y, made of also 3 numbers, 3, 5, and 78. And then the third command asks R to make a plot of X and Y. And this to demonstrate this fourth window here, that when you ask something that has a graphical output, it is produced in this window. And here you can save the chart as a file in different formats, as a graphical file, or save it as a PDF, just give the format of the page, or simply copy it to the clipboard so that you can paste it into your Word document or whatever you do. So essentially what we need to do is to develop our own script, run it, and record the outcome in terms of either chart or table. Sorry, Adiba, was you saying something? I heard something but was not very clear. Okay, no, I thought I had something. So you can also export the result of your analysis into files in different format. So this is the introduction to R that I will give you. It's just to give a very, very overview of the fact that conceptually this is nothing complicated. Of course, the difficulties is learning how many different commands, instruction you can give to the software, and becoming more sophisticated on programming the kind of analysis that you do. Another very important feature of R is that you don't need to just rely on a fixed number of commands. Like, for example, when you use Excel, you have your menu and you can choose a number of things, but for most users, that's it. You cannot create new commands based on different analysis or different procedures that you want to do. R, being instead based on a community of programmers, statisticians, mathematicians, allows the possibility of upgrade the capacity of the software by loading packages that are written by other people and have made available to the community. So in this way, FAO, the statistics division, Sara Viviani, with help from some of us, developed a package that is specific for the analysis of the RUSH model, food insecurity, for the analysis of the FIES data through the RUSH model. And you can go onto the list of available package, and you can see that there are an enormous list of packages available. You can just search for them, and then once you know what to charge, you can install the package in your machine. Now, I have already loaded this package, so it's a warning. If you install, you need to close it, so I won't do it. But I wanted just to show the features of loading packages that are not part of the base program that you download from the internet. Okay, let's go back. If you have worked on a script, you can save it, and then you can load it for next time, so you don't need to type all your command again. You can have the script saved. So this is what I did now. I have a script that is called FIES training, that then I will share with all of you, that now I use to run our analysis. So let's start from scratch. I have opened my script. I have a series of folders in which I keep my data. So if I go to Sierra Leone and I open my FIES training script, this is what I have. So very quickly now, let's go line by line. The first command I use is set the working directory, because I want to make sure that all the data input and output happen in the same directory. So I am pointing it to the position in my computer where the data is. Then I need to use the 3 packages which are needed to do the analysis of the FIES data, to import data from different formats like Stata and SPSS. But these are just details. So now I have data provided in a SAP format. This is SPSS. And actually I see, okay, well. Now this is another one. Okay. Sorry, I loaded the wrong script. Yeah, I loaded the one from Sierra Leone, apologies, instead of the one from South Sudan. So now, here, I'm loading the right file, the round 23 file and the round 25. So here now, let me get rid of the previous one because it's not what I need. So here you see I have, once I have loaded my data, I have tables in my archive. I can look at them. And Nicholas will recognize that. So there are, for example, in round 23, variable x1, x2, x3, x4, x5, x6, x7, and x8. And these are just the FIES questions. As you can see, they are already coded as 0 and 1. And then in this file, there are also questions that concern the household hunger score. So from G1 to G6, we have household hunger score question. And these are similar to what we discussed before. The response is not 0 and 1, but 1, 2, and 3, depending on whether this was rarely, sometimes, or often. Now, on line number 6, I just extract the FIES data. So I'm using the command called subset, and this is extracting just 8 variables, which are the FIES variable. And then, in case there are some values that are not coded like 1, and indeed here there are also some data coded like 98 or 99. This is a convention that normally is used when the data are missing. So before proceeding in the analysis, I have to make sure that these are not intended as numbers. And so I have line number 7 that says that every time there is a number that is greater than 1, this is actually missing. In our language, it's not available. I do the same thing for the round 25. And then for convenience, I assign standard names to this variable. Instead of x1, x2, x3, j1, j2, and j3, I give them names. So that now I have worried, healthy, few foods, which are the traditional names that we assign to the FIES item. And now let's start the analysis. So the command that I use is this very simple command rm.w, which stands for Rush Model Weights. And this will accept a series of options, but it can also work with just one input, which is the data that you want to use. Then, of course, you could give other alternative command, like using the weights, using the options, whether you want to have the output saved in a file, etc., etc. But for now, for this demonstration, this is not necessary. The RM weight package comes with a manual. You can find all the description in the manual. So now I run this command. And when a command run, you notice that when the computer is doing some calculation, there is this red mark that appears. Once this is finished, then you have the result of this command saved into a structure that I called, this is the name I gave, result round 23, which appear here. And this is a large list of 25 elements, because in this list I have several things. If you remember the rush model we discussed last time, the output of running this maximum likelihood procedure will be the parameters of severity of the items, parameters of severity for the respondent, the raw score, all statistics with the residuals that we can use to do tests. So everything we need is now into this result structure, is a list technically, with 25 different elements. How to access the element from a list is by using this feature of the $sign. So here now on line 13, I am asking R to calculate the standard deviation of the vector B, which is one of the elements of my result list. Remember B, this is the convention we use, this is the severity parameters. Standard deviation of the severity parameter is 0.8, 0.79. Here is another example. Another output of the rush model is the reliability coefficient. So in this application, the reliability coefficient is 69%. 69% means that 69% of the variability in the data can be attributed to the rush model. Then I could also have the matrix of residuals. Remember, we discussed that once you have estimated the parameters, you can calculate the predicted probability of having a certain response, and then you can make the difference between the actual response and the predicted response, and this is the residuals. And you see, when I write the $, it gives me all the elements. This is a large matrix of residuals, the differences between the actual response and the probability that I will have that response. So these are all numbers that go between -1 and +1. In some cases, they are very large. In some other cases, they are very small. And this is the basis for us to conduct our statistical test. One interesting analysis of the results is to do a principal component to detect whether or not the residuals still have some unexplained underlying dimension. And for example, R can be used to do a principal component analysis, and to, in this case, I'm presenting the scree plot. The scree plot is a plot that lists the principal component, and the variance that is explained by each component. Ideally, we would like to have this plot as a straight line, meaning that the several components do not differ too much in terms of the variability that they can explain. In this case, there is a elbow-shaped scribblot. This means that in the data, which in this case are my residuals, there is still the first principal component, the first dimension, that captures significantly more variance than all the rest, which means that there is something problematic in this data, in the sense that applying the Rush model, assuming that all these data contribute to one underlying dimension, here there is evidence that this is not enough, that there is still other information in the data that is independent from the latent rate that I'm measuring. And so remember that we discussed one of the important statistics is the in-fit statistics. And if I check, I notice that there is one item, the healthy item, that has an in-fit larger than 1.3. I can actually show all of them. So the healthy item has an in-fit that is larger than 1.3, meaning the people responded to this healthy item in a way that is not consistent with the way in which they have responded to the other item. It's like this item doesn't belong to the rest. And this may be one reason why we see still some structure in the residual. So what is the consequence? That we cannot use this item in this scale if we want to rely on the property of the Rush model. So the next step is to exclude that item from the analysis. So in this line 23 now, I am redefining my matrix. Now it has 1, 2, 3, 4, 5, 6, 7, and 8 items. If I run this command, note the use of the square parentheses. Square parentheses are used to select items within a matrix. And I have the first argument empty, means I want to have all rows. And the second argument is a subset of the columns. So I want to have only columns 1, 3, 4, 5, 6, 7, and 8. Alternative, I can write -2, means that from all the columns, take out column 2. That's an equivalent way of writing it. So if I do this now, my column no longer have the healthy items. It has only worried, then few food, skipped, ate less, run out, and hungry. Yes, I am excluding completely the column numbers 2. So now I have, notice the difference, FIES are 23, the same number of observations, but only 7 variables. So somebody is asking me privately, but there is no reason to be private. Probably this is Sattar asking. Yes. I changed the order of the questions so that when I loaded the data from the 23rd round, I'm loading them in the same order in which they're asked. For round 25, I am switching the position of items 4 and 5. Now, Nicholas, this is very important because I am 100% sure that at some point, at some moment, in the coding of this data or in the programming, whether I assume it was a CATI machine, these two questions have been switched. And I will show you why I think that is the case. So now I can run the analysis again. So I have to rerun the analysis, this time only using 7 items. And I immediately go to see whether the reliability has changed. And of course, I have one less item, so the model is less powerful in detecting variability, so it's expected to have a lower reliability. But I also want to see whether there is an impact on the scree plot. And you see that indeed, excluding that item improves quite considerably the situation, so that now the difference between the first and the other is not as extreme as before. As I say, ideally, this should be a straight line. But let's check now if there is any item with infit greater than 1.3. And now all items are below 1.3. The first one is still problematic. It's almost 1.3, meaning that potentially there is still something not quite clear on the question worry. And this might explain this little difference. But because it's not so large, we can still keep it and do the analysis. But this is an indication that we need to look into the way in which this question has been asked and understood by people, because there might be some problems. But now let me move on the round 25. Let's see if there is any item that has infit greater than 1.3, and in this case, all items have infit less than 1.2. Let's see if there is something, sorry. The standard deviation is quite higher. The reliability is 71%. Sorry, there is an error in my code. Oh, no, sorry, forget about this. I was making an exercise with different version of the model, and now I only serve one. This is the scree plot of the result. I don't need all this. The scree plot of the result of the 25th round, and you see no problem here. So one first assessment in the 25th round data collection, things went better than in the 23rd round. Probably even experience of people having collected the data. I don't know, Nicholas, if you did any change in the wording of the healthy question, but in the 25th round, we see no problem. Now, of course, now I have two scales. One is the 25th round with all 8 items, and one is the 23rd round in which I only have 7 items. Can I compare them? Sorry, I have a couple of questions before I go further. So from information of the group, Nicholas has written that in round 23 of the FSNS was the very first time that FIES was applied in South Sudan. Then Danvers has a question. Does the number of items you removed have an impact on the final result? And the answer is absolutely yes, in a sense that before comparing the results using only 7 items with results using all 8 items, you need to make first a calibration of the 2 scales. Imagine, we discussed last time that the simplest measure that you can obtain from the Rush model is the raw score. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. But now, if we exclude one item, the raw score can only go from 0 to 7. So, can I compare raw score across these 2 applications? And the answer is no, because in the first case, I only have 7 points that span the entire range of severity. In the second case, I have 8 points. So they are a little bit closer to each other. It's like with more items, I have more discriminating ability. It's like, I don't know, if I want to measure something with a ruler, if I have more ticks in the ruler, I can be more precise. But if I number the rules, the ticks from 1 to 10, and with another ruler only 1 to 5, they are not directly comparable. Number 3 in the first scale cannot be compared to number 3 on the second scale. So that is one important implication. You can do it, you can use the scale. You have to, you must drop the item that don't work, but before comparing the result, you have to do this equating, which is the next step. So now I have 2 scales, one based on 7 items and one based on 8 items. And I am just running a few commands and then I will explain what is the meaning. What I have done is I've done the equating, creating an adjustment of the scale used in the 23rd round to make it comparable to the scale used in the 25th round. And now what I do, I simply plot the severity parameter, the parameters B, in the 2 scale. And so let's see if this works. I have a plot that shows the position of this parameter in the 2 scales. The red one is the 25th round. The black one is the 23rd round. And this is a 45-degree line, which means that each of these dots is measured with the severity that the item demonstrates in the 23rd round on the horizontal axis and the severity of the item demonstrated in the 25th round on the vertical axis, ideally, they should be sitting on the 45-degree line. And now you see why there are two items that are not equivalent. Worried and few foods, they are not equivalent. And that is why they have been excluded from the set of common items. Now, Nicholas, this is a question for you. Is there a possibility also that between the 23rd and the 25th round, there has been a switch of these two columns? The reason is because if I consider the severity of worried and the severity of few food inverted in one of the two scales, they will become almost perfectly aligned on the 45-degree line. And this is what I did already for 8 less and skipped. So in principle, when you apply the same scale in the same community, not so far apart, you would expect a very close correspondence of this. And this is more or less the same community because it's the same population, only how far apart were these two rounds? I think less than 1 year apart, no? I'm expecting a response from Nicholas, but then. Nick?
Yeah, so we had a discussion with...
I barely hear you. I don't know if others also have the same problem. 1 year apart.
Sorry,
Okay.
I'm always having an issue with my mic.
Yeah, a little better. For a moment, I heard you well, but now it's still low.
Can you hear me now?
Yes, this is better.
Okay, looks like I have to tilt my head in a funny angle. So we discussed with Sata and shared the tools. Then he looked at them and I think did the switch that you're talking about, and they were able to align, if I'm not wrong.
Yeah, I did that. I did that, yeah. And I aligned 8 less and skipped perfectly. But now I'm asking you whether the same issue may be between worried and few foods. I'm not that confident because the infit of few food is still, of worried, sorry, still quite high. So I wouldn't be too much concerned. But I'm noting that there is some evidence that there may be just some confusion between the columns. And this is only based on the results of the analysis of the data. But let's not make any unnecessary assumption. The only element that I want to highlight is that if I want to, and this goes back to Denver's question, if I want to compare this result, I have to make sure that I identify the items that can be considered common among the two applications, and I transform one of the two scales so that these items are as close as possible to each other, so that we are measuring the same thing irrespective of we use the 23 round scale or the 25th round scale. And this is what is embedded in this set of lines. So I first need to identify the set of common items. And these are the 5 common items. Then what I do is I adjust one of the scale, and I decided to adjust the 23 round to make it comparable to the 25th, in a way that the mean and the standard deviation of the severity of the common item is the same. This is just a linear transformation. It's a rescaling. Remember that we discussed about comparing temperature measured in the Fahrenheit scale and temperature measured in the Celsius scale, no? You cannot compare the numbers. But if you know a set of anchoring points, so for example, I know what is the temperature that the ice melt and what is the temperature that water boils in the two scale, I can make the adjustment. And in fact, you can convert Celsius temperature into Fahrenheit scale and vice versa by, I think it's minus 32, and then multiplied by 5/9. So you have a factor of shifting and a factor of scaling that allow you to convert any number that is measured on the Fahrenheit scale into the equivalent number of the Celsius scale. So for example, 37 degrees Celsius is equal to 98.6 degrees Fahrenheit. 0 degrees Celsius is equal to 21 degrees Fahrenheit. And this is exactly what we are doing here. It's a linear transformation in which there is a shifting factor and a scaling factor. So that if I do this adjustment, sorry, Veronica, you're saying something?
Oh, sorry, I didn't have my microphone silent. I just joined and I didn't know.
Sorry. And you joined just 3 minutes before the meeting ends. So I think you will enjoy looking at the recording.
Yeah.
So what we did is exactly to make sure that the actually, let me put this in the script so we will have it for later. After this adjustment, if I calculate the mean of the set of common items in the 23rd and in the 25th scale, and the 25th is not adjusted, I should have exactly the same number, 0.49, and the standard deviation of the two should also be the same. So this is just a normalization. I'm normalizing the two scales so that the set of common items have the same mean, have the same standard deviation, and that's why when I plot them one against each other, then they are aligned on the same 45-degree line. Okay, and again, we have reached the end of this short hour, and we need to stop now because I need to start another meeting immediately. We will continue next time, and if you agree, we might try and have an additional edition, maybe earlier this week on Monday or Tuesday. But if I need to ask you to collect your availability, if you think that there is a possibility of having another lesson before next Thursday, you let me know by email. Otherwise, I thank you everyone, and I will see you next Thursday. Sorry for the rush, but I now need to close this meeting and see you next time.
Bye, everyone.
Bye.
Bye-bye.
Bye. Bye-bye. Ciao.
Ciao, everyone. Thank you.
Bye.
Thank you.